And your first question comes from CJ Muse with Cantor Fitzgerald. Please go ahead.
Yeah, good afternoon. Thank you for taking the question. I guess for me, Jensen, as test time compute and reinforcement learning show such promise, we're clearly seeing an increasing blurring of the lines between training and inference. What does this mean for the potential future of potentially inference dedicated clusters? And how do you think about the overall impact to NVIDIA and your customers? Thank you.
Yeah, I appreciate that, CJ. There are now multiple scaling laws. There's the pre-training scaling law, and that's going to continue to scale because we have multimodality. We have data that came from reasoning that are now used to do pre-training. And then the second is post-training scaling law, using reinforcement learning human feedback, reinforcement learning AI feedback, reinforcement learning verifiable rewards. The amount of computation you use for post-training is actually higher than pre-training. And it's kind of sensible in the sense that you could, while you're using reinforcement learning, generate an enormous amount of synthetic data or synthetically generated tokens. AI models are basically generating tokens to train AI models. And that's post-training. And the third part, this is the part that you mentioned, is test time compute or reasoning, long thinking, inference scaling. They're all basically the same ideas. And there you have chain of thought, you have search. The amount of tokens generated, the amount of inference compute needed is already 100 times more than the one-shot examples and the one-shot capabilities of large language models in the beginning. And that's just the beginning. This is just the beginning. The idea that the next generation could have thousands times and even hopefully extremely thoughtful and simulation-based and search-based models that could be hundreds of thousands, millions of times more compute than today is in our future. And so the question is, how do you design such an architecture? Some of the models are autoregressive. Some of the models are diffusion-based. Some of the times you want your data center to have disaggregated inference. Sometimes it's compacted. And so it's hard to figure out what is the best configuration of a data center, which is the reason why NVIDIA's architecture is so popular. We run every model. We are great at training. The vast majority of our compute today is actually inference. And Blackwell takes all of that to a new level. We designed Blackwell with the idea of reasoning models in mind. And when you look at training, it's many times more performant. But what's really amazing is for long thinking, test time scaling, reasoning AI models were tens of times faster, 25 times higher throughput. And so Blackwell is going to be incredible across the board. And when you have a data center that allows you to configure and use your data center based on, are you doing more pre-training now, post-training now, or scaling out your inference, our architecture is fungible and easy to use in all of those different ways. And so we're seeing, in fact, much, much more concentration of a unified architecture than ever before.
Your next question comes from the line of Joe Moore with JP Morgan. Please go ahead.
Morgan Stanley, actually. Thank you. I wonder if you could talk about GB200 at CES. You sort of talked about the complexity of the rack level systems and the challenges you have. And then, as you said in the prepared remarks, we've seen a lot of general availability. Where are you in terms of that ramp? Are there still bottlenecks to consider at a systems level above and beyond the chip level? And just, have you maintained your enthusiasm for the NVL72 platforms?
Well, I'm more enthusiastic today than I was at CES. And the reason for that is because we've shipped a lot more since CES. We have some 350 plants manufacturing the 1.5 million components that go into each one of the Blackwell racks, Grace Blackwell racks. Yes, it's extremely complicated, and we successfully and incredibly ramped up Grace Blackwell, delivering some $11 billion in revenues last quarter. We're going to have to continue to scale as demand is quite high and customers are anxious and impatient to get their Blackwell systems. You've probably seen on the web a fair number of celebrations about Grace Blackwell systems coming online, and we have them, of course. We have a fairly large installation of Grace Blackwells for our own engineering and our own design teams and software teams. CoreWeave has now been quite public about the successful bring up of theirs. Microsoft has, of course, OpenAI has, and you're starting to see many come online. And so I think the answer to your question is nothing is easy about what we're doing, but we're doing great, and all of our partners are doing great.
Your next question comes from the line of Vivek Arya with Bank of America Securities. Please go ahead.
Thank you for taking my question. Colette, if you wouldn't mind confirming if Q1 is the bottom for gross margins. And then, Jensen, my question is for you. What is on your dashboard to give you the confidence that the strong demand can sustain into next year? And has DeepSeek and whatever innovations they came up with, has that changed that view in any way? Thank you.
Let me first take the first part of the question there regarding the gross margin. During our Blackwell ramp, our gross margins will be in the low 70s. At this point, we are focusing on expediting our manufacturing to make sure that we can provide to customers as soon as possible. Our Blackwell has fully ramped, and once our Blackwell fully ramps, we can improve our cost and our gross margin. So we expect to probably be in the mid-70s later this year. Walking through what you heard Jensen speak about the systems and their complexity. They are customizable in some cases. They've got multiple networking options. They have liquid-cooled and water-cooled. So we know there is an opportunity for us to improve these gross margins going forward. But right now, we are going to focus on getting the manufacturing complete and to our customers as soon as possible.
We know several things, Vivek. We have a fairly good line of sight of the amount of capital investment that data centers are building out towards. We know that going forward, the vast majority of software is going to be based on machine learning. And so accelerated computing and generative AI, reasoning AI, are going to be the type of architecture you want in your data center. We have, of course, forecasts and plans from our top partners. And we also know that there are many innovative, really exciting startups that are still coming online as new opportunities for developing the next breakthroughs in AI, whether it's agentic AIs, reasoning AIs, or physical AIs. The number of startups are still quite vibrant, and each one of them need a fair amount of computing infrastructure. And so I think the whether it's the near-term signals or the mid-term signals, near-term signals, of course, are POs and forecasts and things like that. Mid-term signals would be the level of infrastructure and CapEx scale out compared to previous years. And then the long-term signals has to do with the fact that we know fundamentally software has changed. from hand coding that runs on CPUs to machine learning and AI-based software that runs on GPUs and accelerated computing systems. And so we have a fairly good sense that this is the future of software. And then maybe as you roll it out, another way to think about that is we've really only tapped consumer AI and search and some amount of consumer generative AI, advertising, recommenders, kind of the early days of software. The next wave's coming. Agentic AI for enterprise, physical AI for robotics, and sovereign AI as different regions build out their AI for their own ecosystems. And so each one of these are barely off the ground, and we can see them. We can see them because, obviously we're in the center of much of this development, and we can see great activity happening in all these different places, and these will happen. So near term, midterm, long term.
Your next question comes from the line of Harlan Sur with JP Morgan. Please go ahead.
Yeah, good afternoon. Thanks for taking my question. Your next generation Blackwell Ultra is set to launch in the second half of this year, in line with the team's annual product cadence. Jensen, can you help us understand the demand dynamics for Ultra, given that you'll still be ramping the current generation Blackwell solutions? How do your customers and the supply chain also manage the simultaneous ramps of these two products? And is the team still on track to execute Blackwell Ultra in the second half of this year?
Yes. Blackwell Ultra is second half. As you know, the first Blackwell was, we had a hiccup that probably cost us a couple of months. We're fully recovered, of course. The team did an amazing job recovering, and all of our supply chain partners and just so many people helped us recover at the speed of light. And so now we've successfully ramped production of Blackwell. But that doesn't stop the next train. The next train is on an annual rhythm, and Blackwell Ultra with new networking, new memories, and of course new processors, and all of that is coming online. We've been working with all of our partners and customers, laying this out. They have all of the necessary information, and we'll work with everybody to do the proper transition. This time between Blackwell and Blackwell Ultra, the system architecture is exactly the same. It's a lot harder going from Hopper to Blackwell because we went from an NVLink 8 system to a NVLink 72 base system. So the chassis, the architecture of the system, the hardware, the power delivery, all of that had to change. This was quite a challenging transition, but the next transition will slot right in. Blackwell Ultra will slot right in. We've also already revealed and been working very closely with all of our partners on the click after that. And the click after that is called Vera Rubin. And all of our partners are getting up to speed on the transition of that. And so preparing for that transition. And again, we're going to provide a big, huge step up. And so come to GTC, and I'll talk to you about Blackwell Ultra, Vera Rubin, and then show you what's the one click after that. Really, really exciting new product. So come to GTC, please.
Your next question comes from the line of Timothy Arcuri with UBS. Please go ahead.
Thanks a lot. Jensen, we hear a lot about custom ASICs. Can you kind of speak to the balance between custom ASIC and merchant GPU? We hear about some of these heterogeneous superclusters to use both GPU and ASIC. Is that something customers are planning on building, or will these infrastructures remain fairly distinct? Thanks.
Well, we build very different things than ASICs. In some ways, completely different. In some areas, we intersect. We're different in several ways. One, NVIDIA's architecture is general. Whether you've optimized for autoregressive models or diffusion-based models or vision-based models or multimodal models or text models, we're great at all of it. We're great at all of it because our software stack our architecture is flexible, our software stack ecosystem is so rich that we're the initial target of most exciting innovations in algorithms. And so by definition, we're much, much more general than narrow. We're also really good from the end to end, from data processing, the curation of the training data, to the training of the data, of course, to reinforcement learning used in post-training, all the way to inference with test time scaling. So we're general, we're end to end, and we're everywhere. And because we're not in just one cloud, we're in every cloud. We could be on-prem, we could be in a robot. Our architecture is much more accessible and a great initial target for anybody who's starting up a new company. And so we're everywhere. And then the third thing I would say is that our performance and our rhythm is so incredibly fast. Remember that these data centers are always fixed in size. They're fixed in size or they're fixed in power. And if our performance per watt is anywhere from 2x to 4x to 8x, which is not unusual, it translates directly to revenues. And so if you have a 100 megawatt data center, if the performance or the throughput in that 100 megawatt or that gigawatt data center is 4 times or 8 times higher, your revenues for that gigawatt data center is 8 times higher. And the reason that is so different than data centers of the past is because AI factories are directly monetizable through its tokens generated. And so the token throughput of our architecture being so incredibly fast is just incredibly valuable to all of the companies that are building these things for revenue generation reasons and capturing the fast ROIs. And so I think the third reason is performance. And then the last thing that I would say is the software stack is incredibly hard. Building an ASIC is no different than what we do. We have to build a new architecture, and the ecosystem that sits on top of our architecture is 10 times more complex today than it was 2 years ago. And that's fairly obvious because the amount of software that the world is building on top of our architecture is growing exponentially, and AI is advancing very quickly. So bringing that whole ecosystem on top of multiple chips is hard. And so I would say that those 4 reasons, and then finally I will say this: just because the chip is designed doesn't mean it gets deployed. And you've seen this, over and over again. There are a lot of chips that get built, but when the time comes, a business decision has to be made. And that business decision is about deploying a new engine, a new processor into a limited AI factory in size, in power, and in time. And our technology is not only more advanced, more performant, it has much better software capability, and very importantly, our ability to deploy is lightning fast. And so these things are not for the faint of heart, as everybody knows now. And so there's a lot of different reasons why we do well, why we win.
Your next question comes from the line of Ben Reitz with Melius Research. Please go ahead.
Yeah, hi, Ben Reitz is here. Hey, thanks a lot for the question. Hey, Jensen, it's a geography-related question. You did a great job explaining some of the demand underlying, factors here on the strength. But U.S. was up about $5 billion or so sequentially. And I think, there is a concern about whether U.S. can pick up the slack if there's regulations towards other geographies. And I was just wondering, as we go throughout the year, if this kind of surge in the U.S. continues and it's going to be, whether that's okay, and if that, underlies your growth rate, how can you keep growing so fast with this mix shift towards the U.S.? Your guidance looks like China is probably up sequentially. So Just wondering if you could go through that dynamic and maybe Colette can weigh in. Thanks a lot.
China is approximately the same percentage as Q4 and as previous quarters. It's about half of what it was before the export control, but it's approximately the same in percentage. With respect to geographies, the takeaway is that AI is software. It's modern software. It's incredible modern software, but it's modern software. And AI has gone mainstream. AI is used in delivery services everywhere, shopping services everywhere. And if you were to buy, a quart of milk is delivered to you, AI was involved. And so almost everything that a consumer service provides, AI is at the core of it. Every student will use AI as a tutor. Healthcare services use AI. Financial services use AI. No fintech company will not use AI. Every fintech company will. Climate tech company uses AI. Mineral discovery now uses AI. The number of every higher education, every university uses AI. And so I think it is fairly safe to say that AI has gone mainstream and that it's being integrated into every application. And our hope is that of course the technology continues to advance safely and advance in a helpful way to society. And with that, we're I do believe that we're at the beginning of this new transition. And what I mean by that in the beginning is remember, behind us has been decades of data centers and decades of computers that have been built. And they've been built for a world of hand coding and general purpose computing and CPUs and so on and so forth. And going forward, I think it's fairly safe to say that world is going to be almost all software will be infused with AI. All software and all services will be ultimately based on machine learning, and the data flywheel is going to be part of improving software and services, and that the future computers will be accelerated. The future computers will be based on AI. And we're really at 2 years into that journey. And in modernizing computers that have taken decades to build out. And so I'm fairly sure that we're in the beginning of this new era. And then lastly, no technology has ever had the opportunity to address a larger part of the world's GDP than AI. No software tool ever has. And so this is now a software tool that can address a much larger part of the world's GDP, more than any time in history. And so the way we think about growth and the way we think about whether something is big or small has to be in the context of that. And when you take a step back and look at it from that perspective, we're really just in the beginnings.
Your next question comes from the line of Aaron Rakers with Wells Fargo. Please go ahead. Aaron, your line is open. Your next question comes from Mark Lipacis with Evercore ISI. Please go ahead.
Hi, that's Mark Lipacis. Thanks for taking the question. I had a clarification and a question. Colette, for the clarification, did you say that enterprise within the data center grew 2x year-on-year for the January quarter? And if so, would that make it faster growing than the hyperscalers? And then Jensen, for you, the question, hyperscalers are the biggest purchasers of your solutions, but they buy equipment for both internal and external workloads being cloud services that enterprises use. So the question is, can you give us a sense of how that hyperscaler spend splits between that external workload and internal, and as these new AI workloads and applications come up, would you expect enterprises to become a larger part of that consumption mix? And does that impact how you develop your service, your ecosystem? Thank you.
Sure. Thanks for the question regarding our enterprise business. Yes, it grew 2x and very similar to what we were seeing with our large CSPs. Keep in mind, these are both important areas to understand. Working with the CSPs can be working on large language models, can be working on inference in their own work, but keep in mind that is also where the enterprises are surfacing. Your enterprises are both with your CSPs as well as in terms of building on their own. They're both correct, growing quite well.
The CSPs are about half of our business. And the CSPs have internal consumption and external consumption, as you say. And we're of course, used for internal consumption. We work very closely with all of them to optimize workloads that are internal to them because they have a large infrastructure of NVIDIA gear that they could take advantage of. And the fact that we could be used for AI on the one hand, video processing on the other hand, data processing like Spark, we're fungible. And so the useful life of our infrastructure is much better. If the useful life is much longer, then the TCO is also lower. And so the second part is how do we see the growth of enterprise or not CSPs, if you will, going forward? And the answer is, I believe long term, it is by far larger. And the reason for that is because if you look at the computer industry today, and what is not served by the computer industry is largely industrial. So let me give you an example. When we say enterprise, and let's use a car company as an example because they make both soft things and hard things. And so in the case of a car company, the employees would be what we call enterprise. And agentic AI and software planning systems and tools, and we have some really exciting things to share with you guys at GTC. Those agentic systems are for employees to make employees more productive, to design, to market, to plan, to operate their company. That's agentic AIs. On the other hand, the cars that they manufacture also need AI. They need an AI system that trains the cars, treats this entire giant fleet of cars. And, today, there's a billion cars on the road. Someday, there'll be a billion cars on the road, and every single one of those cars will be, robotic cars. And they'll all be collecting data, and we'll be improving them using an AI factory. Whereas they have a car factory today, in the future, they'll have a car factory and an AI factory. And then inside the car itself is a robotic system. And so, as you can see, there are three computers involved. And there's the computer that helps the people. There's the computer that builds the AI for the machineries. It could be, of course, a tractor. It could be a lawnmower. It could be a humanoid robot that's being developed today. It could be a building. It could be a warehouse. These physical systems require a new type of AI we call physical AI. They can't just understand the meaning of words and languages, but they have to understand the meaning of the world. Friction and inertia, object permanence and cause and effect, and all of those type of things that are common sense to you and I, but AIs have to go learn those physical effects. So we call that physical AI. That whole part of using agentic AI to revolutionize the way we work inside companies, that's just starting. This is now the beginning of the agentic AI era, and you hear a lot of people talking about it, and we've got some really great things going on. And then there's the physical AI after that, and then there are robotic systems after that. And so these three computers are all brand new, and my sense is that long-term, this will be by far the larger of them all, which kind of makes sense. The world's GDP is represented by either heavy industries or industrials and companies that are providing for those.
Your next question comes from the line of Aaron Rakers with Wells Fargo. Please go ahead.
Yeah, thanks for letting me back in. Jensen, I'm curious, as we now approach the 2-year anniversary of really the Hopper inflection that you saw in 2023 in Gen AI in general, and we think about the roadmap you have in front of us, how do you think about the infrastructure that's been deployed from a replacement cycle perspective, and whether, if it's GB300 or if it's the Rubin cycle where we start to see maybe some refresh opportunity? I'm just curious to how you look at that.
I appreciate it. First of all, people are still using volts and pascals and amperes. And the reason for that is because there are always things that, because CUDA is so programmable, you could use it right. Well, one of the major use cases right now is data processing and data curation. You find a circumstance that an AI model is not very good at. You present that circumstance to a vision language model. Let's say it's a car. You present that circumstance to a vision language model. The vision language model actually looks at the circumstance and said, "This is what happened, and I wasn't very good at it." You then take that response, the prompt, and you go and prompt an AI model to go find in your whole lake of data other circumstances like that, whatever that circumstance was. And then you use an AI to do domain randomization and generate a whole bunch of other examples. And then from that, you can go train the model. And so you could use the amperes to go and do data processing and data curation and machine learning based search. And then you create the training data set, which you then present to your Hopper systems for training. And so each one of these architectures are they're all CUDA compatible, and so everything runs on everything. But if you have infrastructure in place, then you can put the less intensive workloads onto the install base of the past. All of our GPUs are very well employed.
We have time for one more question, and that question comes from Atif Malik with Citi. Please go ahead.
Hi, thank you for taking my question. I have a follow-up question on gross margins for Colette. Colette, I understand there are many moving parts, the Blackwell yields and NVLink 72 and Ethernet mix, and you kind of tiptoed the earlier question if April quarter is the bottom. But second half would have to ramp like 200 basis points per quarter to get to the mid-70s range that you're giving for the end of the fiscal year. And we still don't know much about tariffs impact to broader semiconductors. So what kind of gives you the confidence in that trajectory in the back half this year?
Yeah, thanks for the question. Our gross margins, they're quite complex in terms of the material and everything that we put together in a Blackwell system. Tremendous amount of opportunity to look at a lot of different pieces of that on how we can better improve our gross margins over time. Remember, we have many different configurations as well on Blackwell that will be able to help us do that. So together, working after we get some of these really strong ramping completed for our customers, we can begin a lot of that work. If not, we're going to probably start as soon as possible if we can. And if we can improve it in the short term, we will also do that. Tariffs, at this point, it's a little bit of an unknown. It's an unknown until we understand further what the U.S. government's plan is, both its timing, its where, and how much. So at this time, we are awaiting. But again, we would, of course, always follow export controls and/or tariffs in that manner.
Ladies and gentlemen, that does conclude our question and answer session. I'm sorry.
Thank you. No.
And we're going to open up to Jensen, and I believe he has a couple things.
I just wanted to thank you. Thank you, Colette. The demand for Blackwell is extraordinary. AI is evolving beyond perception and generative AI into reasoning. With reasoning AI, we're observing another scaling law, inference time or test time scaling. The more computation, the more the model thinks, the smarter the answer. Models like OpenAI's Grok 3, DeepSeek R1 are reasoning models that apply inference time scaling. Reasoning models can consume 100 times more compute. Future reasoning models can consume much more compute. DeepSeek R1 has ignited global enthusiasm. It's an excellent innovation, but even more importantly, it has open sourced a world-class reasoning AI model. Nearly every AI developer is applying R1 or chain of thought and reinforcement learning techniques like R1 to scale their model's performance. We now have 3 scaling laws, as I mentioned earlier, driving the demand for AI computing. The traditional scaling laws of AI remains intact. Foundation models are being enhanced with multimodality, and pre-training is still growing. But it's no longer enough. We have 2 additional scaling dimensions. Post-training scaling, where reinforcement learning, fine-tuning, model distillation require orders of magnitude more compute than pre-training alone. Inference time scaling and reasoning, where a single query can demand 100 times more compute. We designed Blackwell for this moment, a single platform that can easily transition from pre-training, post-training, and test time scaling. Blackwell's FP4 transformer engine and NVLink 72 scale-up fabric and new software technologies let Blackwell process reasoning AI models 25 times faster than Hopper. Blackwell, in all of its configurations, is in full production. Each Grace Blackwell NVLink 72 rack is an engineering marvel. 1.5 million components produced across 350 manufacturing sites by nearly 100,000 factory operators. AI is advancing at light speed. We're at the beginning of reasoning AI and inference time scaling. But we're just at the start of the age of AI. Multimodal AIs, enterprise AI, sovereign AI, and physical AI are right around the corner. We will grow strongly in 2025. Going forward, data centers will dedicate most of CapEx to accelerated computing and AI. Data centers will increasingly become AI factories, and every company will have them, either rented or self-operated. I want to thank all of you for joining us today. Come join us at GTC in a couple of weeks. We're going to be talking about Blackwell Ultra, Rubin, and other new computing, networking, reasoning AI, physical AI products, and a whole bunch more. Thank you.
This concludes today's conference call. You may now disconnect.